So I'm going to talk to you about two special powers or indices. They're the only two that we can actually present in a visual way in mathematics. Now, you've probably heard of a square number before, and you've probably seen it written something like this. So for instance, 7 squared, and I'm just going to write that in words so you can see it as well, equals 7 to the power of 2. So that means 7 times 7. And that equals 49. So 49 is therefore a square number. Now, why we have square numbers is because they tell us the area of a square with certain side lengths. So for example, in this case, it'll take me a little while to draw. If I have a square, both sides, well, all sides are the same length. And we show this with a line. A line on each side shows that they're all the same length because we would measure a line with a straight length. So if this is 7, this will be 7, this will be 7, and this will be 7. So I'm just going to underline this one with pink, and you'll see why in a second. If I've got 7 lines, 2, 3, 4, whoops, 5, 6, 7. That means I've got 7 going this way, and then this way, underline this one with green, I've got 7 going this way. 1, 2, 3, 4, 5, 6, 7. Good. Now notice that if I numbered these boxes, because I've got 7 centimetres going this way, and I've got 7 centimetres going this way, I would have 49 centimetres squared, or square centimetres. So let's label them 1, 2, 3, 4, 5, 6, 7, 8, 9, oop, missed, 10, 11, 12, 13, 14, 15, 16, it's getting really boring really fast, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. Do you notice that 7 squared tells you the area of a square with side lengths of 7? So that's what a square number means. A square number tells you the area of the square. The inverse of that, which means the opposite way around, would be the square, get a different colour to make it stand out, the square root. So for instance, if you had the square root of 49, that means what number is multiplied by itself to make 49, which we know is 7. So 7, or the square root, tells us the side length of the square that would give us an area of 49. So a square number tells you the area of a square with the side length of 7, whereas a square root tells you the side length of a square when you already know its area, which here we know is 49. So now let's talk about cube numbers. Cube numbers are something to the power of 3, and this is why. If we have a side length on a cube, the whole point of a cube is that every single side length is identical. So all of these sides, and all of the ones that you can't see, are all worth 2. So if I'm working out the volume, because it's a 3D image, I'm going to have to work out my square at the front and then multiply how far back it goes or how deep it is. So I'm going to work out its cross section and multiply it by its depth. So what I'm going to do here is work out the cross section by 2 times 2, which will give me this, and then I'm going times by the depth, which is also 2. Now this would be 2 to the power of 3, which would be 2 times 2, which is 4, times 2, which is 8. And that's why anything to the power of 3 is called a cube, because it gives you the volume of a cube with a side length of the base you're given. So I know for a cube with a side length of 2, the volume is going to be 8 units cubed. And that says units because apparently I can't spell. There we go, units, that's an N. The same system works for cube roots. So a cube root will calculate the side length given a volume. So for example, if I was given a cube root of 64, what that means is my volume of my cube is 64. Sorry, that's a really bad unit square. That's a really bad square. It's cubed, sorry, tell a lie. What a donut. 64 units cubed. And by writing this in a calculator, it will tell me what item is multiplied by itself 3 times to make 64. And the answer to my side length problem is 4, because 4 times 4 times 4 equals 64. So my cube, my side length of my cube with a volume of 64 has to be 4, because 4 times 4 is 16, 16 times 4 is 64. And that's why usually when we talk about special indices, we only mention square numbers and cube numbers because they're the only two that we can see in real life. The rest of the time we would say something like x to the power of 4, or x to the power of 9, or maybe x to the power of 0, or x to the power of minus 23. But whenever we write x to the 3, that is called a cube number, because it's something times itself three times, which should give us the volume of a cube. Or a square number is x to the power of 2, because that gives you the area of a square. And a square root looks like this, and that tells you the side length of a square when your area is inside, and a cube root gives you the side length of a cube when the volume is written inside the cube root.